Okay, thank you for joining us today. This is webinar 27 in the series. We're going to be talking about COPA RF 2017, and we're going to be looking at the assembly check and regrind rolls functionality that's coming. So today's topics, we're going to be talking about the COPA roll scanner, the roll lifecycle management tool, and COPA RF design, and the interoperability between the individual solutions. Roll lifecycle management, how scanned rolls can be directly loaded into an existing roll design made with COPA RF. And assembly check, whereby the position of the individual roll is a result of the actual assembly. And finally, regrind roll, the functionality for a fast and easy way to calculate how the roll contours need to be reworked, make them usable essentially. So you see here 5 pillars of the roll lifecycle management. This is a closed loop management tool with COPA RLM. So for our design and simulation, you can see the development of the project and using the roll smart search to try and populate that project to develop a roll design. Ultimately, we simulate this with finite element analysis. Then we move on to roll making, delivery, and then quality control with our roll scanner, the inspection against the designed roll. And of course then moving on to the roll stocking. From here we can then move on to our tooling setup, production, quality assurance and roll stock from the production and quality elements of the loop. So we take rolls scanned with the COPA roll scanner. We transfer these rolls, the scanned rolls, directly to the COPA roll lifecycle management database. And so we're not only just then feeding rolls from the new COPA RF design into the database, also the rolls, the physical rolls themselves. And we can collect these scanned contours of the rolls and feed them into our RF design. So the roll lifecycle management database stores all designed and scanned roll contours. And this ultimately allows for continuous monitoring of the roll wear and the roll quality throughout the product lifecycle. So now to talk about assembly check and how that fits in. So these are the individual steps. So first of all, the roll tooling is designed with COPA RF. The rolls are manufactured and then they're scanned with the COPA roll scanner. And the scanned contours are then directly transferred to the COPA RLM database. And in COPA RF, the design and the scanned contours can be directly overlaid and compared. The identification of our rolls and the individual rolls is all done via a unique roll numbering system. Okay, so then any problems, e.g. with roll widths or forming roll radii, will be immediately visible. The first roll is aligned with the machine side and all following will be aligned to the previous roll. So ultimately a setup of multiple rolls with accumulating tolerances can easily lead to a wrong position of the bend zone, and we can identify this. And most importantly, for a lot of roll forming companies nowadays, any roll modifications made during the setup and verification stages will be visible, meaning the tooling design itself can instantly be updated. And that's what I'm going to sort of show you now. So here you can see an additional benefit. The assembly check supplies a detailed information about all of the roll positions in the assembly and shows offsets in the positions due to deviations in the roll width. So here you can see in the table, for example in station 10, whereby we have a cumulative maximum deviation and axial deviation there of 1.58 millimeters. And you can see the regrind on the radial we have available there is 1. So that's our offset. So now let's see how that gets displayed on the screen. So for both tube designs and profiles, the software supplies detailed information about roll positions in the assembly. It shows the offset in the positions due to the deviation in roll width. So first of all, you can see here the magenta. That's our design contour, our desired contour, I like to think of it. And then you see our red contour, the scan contour, which is what we actually have, what was produced at the CNC machine. Then you can see in blue the rework contour and what's required. What's important to understand here, we can see now the width here has grown of the cylinder roll in the center. So this additional material here has now given us an offset of the forming position of this flange roll. So the blue contour there, excuse me, gives me the position whereby what we would need to do to cut this roll to make it usable. And then if we consider this with tube rolls, obviously it's quite common for tube rolls to be recut. So for recutting of tube rolls, the diameter reduction is even easier to define. You can see an example of that here. When we consider the regrind roll benefits now, without a Copra roll scanner and Copra RF, it can take more than 100 engineering hours to determine the regrind contour of worn tooling. So with an existing Copra roll design, the regrind contour can instantly be defined. The required time to do this is about 5 hours to scan the rolls of a roll tool set. So if we compare that to 100 engineering hours, that's a 95-hour saving. So let's imagine we just have the roll design now only as AutoCAD drawings. So the rolls also need to be transferred into Copra. And to do this, we just add an additional 3 hours. So again, it's still a 92-hour saving. And then finally, when having no design data at all, the tooling needs to be re-engineered from scans. So we need to add an additional 8 hours. So that's a 16-hour loss. So there now we're talking a saving of 84 hours compared to using traditional methods whereby there's over 100 engineering hours used. So in order to do that, you have to transfer the roll designs to the Copra Roll Lifecycle Management tool. So in order to make us use the regrind roll functionality in assembly check, an existing roll design has to be transferred to the RLM database. So there are 3 different possibilities to do this. We can import the scan contours from the roll scanner, as I mentioned. We can import from the AutoCAD drawings, and we can import from existing Copra projects. So let's talk about the AutoCAD import. So with the AutoCAD import, this provides easy transfer of tool designs from AutoCAD drawings. We can take information on single rolls from our drawings. We'll just identify the contour and the roll numbers by mouse clicks. And then we assign the roll properties such as the bore hole, the diameter, stamp groove, and so on. The next possibility to transfer existing rolls is the Copra roll import function. Copra roll import provides easy transfer of rolls from AutoCAD drawings and creates the respective assembly in the Copra project. So we take information of a roll assembly directly from AutoCAD drawings. All we have to do is define the reference point in the drawing and in Copra RF, and providing the roll contours are designed correctly and in a proper way. In other words, there is a fitting layer structure, no gaps, contour is good, then the roll can automatically be transferred to Copra RF. Then we get a complete tooling design. This can be easily transferred in a relatively short time. Now when we talk about the roll scanner, the Copra roll scanner interface provides easy transfer of tools without any documents. So we just literally scan existing rolls and transfer the measured contours to the Copra RLM database. Just to point out, for more information on the Copra roll scanner, this can be found on our website under the product section and the Copra roll scanner. And finally, you're invited to a live presentation of this at the Tube Show in April in Dusseldorf. You can see here we'll be in Hall 4, booth F19, where you'll be able to see this and other new exciting Copra RF 2017 features perform live, as we will have a roll scanner there and the latest software available for you to see this demonstration. And finally, more information about DataM. You can follow us on Twitter for all the latest news and events on seminars, webinars and exhibitions we'll be attending. All of our recent videos can be found on our website and also on our YouTube channel, and you can subscribe there at DataM 2012. And more information about DataM and our employees are also available on LinkedIn. So it leaves me to say thank you for your attention. I hope you found this informative and it gives you some food for thought of how you could use these features. I wish you the very best. Have a good day. Thank you. Goodbye.